Yes, in first video I have discussed the behavior of conducting material in electric field. Now we will discuss the behavior of non-conducting material in electric field. Actually, these notes are very useful for you, and these are sufficient. Just you write all the things in your notebook, and which are complete notes. So behavior of non-conducting material in an electric field. Non-conducting material, these are classified into two types, polar molecules and non-polar molecules. Polar molecules, first of all we will discuss the polar molecules. Polar molecules in a molecule in which the center of positive charge and center of negative charge does not coincide. Means that is a hydrogen example, that is a H2O. H2 is there, means hydrogen, the center of hydrogen it is there and center of oxygen is there, and which are not coinciding to each other, which are not coinciding. Here oxygen center which is not coinciding with this one. In case of a HCl also, HCl, just we take an example of a HCl, and just that is H is there, H or Cl. So the center of this hydrogen and center of chlorine which are not coinciding to each other, such molecules are known as the polar molecules. And next thing, polar molecules have a asymmetrical shape, means there is no symmetrical shape, means asymmetrical shape, and H and Cl means there is a distance between them, and positive charge and negative charge, here positive charge and negative charge, there is a distance, so they have a permanent dipole moment. These molecules, polar molecules, have a permanent dipole moment. In the absence of external electric field, the net dipole moment of polar molecules is zero because they form the closed chain. This one is negative charge and it is a positive charge, negative charge and positive charge, negative charge and positive charge, and negative charge and positive charge. These form the closed chain. So net dipole moment, it is equal to zero in the absence of electric field. Electric field is equal to zero. But when we apply the electric field, these each dipole experience a force and which align along the direction of electric field, So here I have written, in the presence of an external electric field, each dipole experiences a torque and which tends to align the molecule along the direction of electric field. The total dipole moment of all molecules is equal to the vector sum. Because dipole moment is a vector quantity, so there is a vector quantity. So the dipole moment of substance has a finite value, and polar molecules does not have any additional dipole moment. There is no additional dipole moment. So these are the polar molecules. But in case of a next non-polar molecules, which are just opposite to the polar molecules, here the molecule in which the center of positive charge and center of negative charge which are coincide to each other, that is a positive charge and that is a negatively charged electron revolving around it, and their center which are coinciding to each other, such molecules are known as the non-polar molecule. Example: oxygen, nitrogen, methane, benzene, etc. These are the non-polar molecules. And the center of positive charge and center of negative charge which are not separated by any distance, so there is no permanent dipole moment. The permanent dipole moment of these molecules in the absence of electric field is equal to zero, and these non-polar molecules are in symmetrical shape. These are in symmetrical shape. Here I have written, in the absence of external electric field, the dipole moment of non-polar molecule is zero. Clear? Next, when we apply the external electric field, then positive charge and negatively charged electron experience a force but in opposite direction. Positive charge experience a force along the direction of electric field, but a negative charge experience a force but in opposite to the electric field. These forces are pulling the charges. These forces means these forces are pulling the charges. The separation between the charges continue till the forces acting on them are balanced by the internal force. There is a electrostatic force between them, and due to electric field these are also experience a force when they balance to each other. So now there is a gap between the positive charge and negatively charged particles, so they have a additional dipole moment. Means now non-polar molecules becomes polar molecules, so the dipole moment of the molecules is known as the induced dipole moment, and that is also known as the additional dipole moment. When we remove the electric field, again the induced dipole moment disappear as the external electric field is removed. क्लियर? एक्चुअली ये पूरा का पूरा थियोरेटिकल पार्ट है और ये थोड़ा सा बस समझना ही पड़ेगा और समझ के बस कुछ डेफिनेशन लर्न कर लेनी है. इट्स एनफ. नेक्स्ट, पोलराइजेबिलिटी means it measures the induced dipole moment of a molecule is directly proportional to the applied electric field. P is directly proportional to the E. So P means that is a dipole moment is directly proportional to the epsilon naught E. Epsilon naught due to means it is in a vacuum, that's why we have written epsilon naught. So P is equal to dipole moment is equal to alpha, that is the atomic polarizability, and epsilon naught permittivity of the vacuum and electric field, and here alpha is equal to P upon epsilon naught E, and SI unit of alpha atomic polarizability, that is meter cube. Next setting, that is a dielectric. Dielectrics, these are also known as the non-conducting material. Actually, there is a contradiction. Some books we will get dielectrics are the insulating material, and some books we will get dielectrics are the semiconducting material. But at the class 12th level, we just consider dielectric are the non-conducting material, means dry air and dry wood. Means semiconducting and insulating material, actually they have explained the dielectric on the basis of forbidden energy gap. Later on, in case of in the unit of a semiconductor, we will discuss this topic again, what do you mean by dielectrics. But here non-conducting materials are the dielectrics. Polar molecules means the center of positive charge and center of negative charge does not coincide. It means polar molecules are placed in an electric field, no additional dipole moment. उनका कोई additional dipole moment नहीं. But in case of a non-polar molecules, they have a additional dipole moment because here positive charge and negative charge experience a force. It means appreciable layer of positive and negative charges are created on the opposite faces of the substances. Means यहाँ पर ये कि when non-conducting material which are placed in an electric field, then induced charge produced on their surfaces, on their faces. Induced charge produced on their faces. Induced charge. So ये example है hydrogen gas, air, glass, mica, transformer, oil, paraffin wax. These are the examples of dielectrics. Dielectrics are used to increase the capacitance of a capacitors. Water is a polar molecules, but transformer oil is a non-polar molecule. So transformer oil is better dielectric.